this video, we will discuss about allotropes of carbon. So, carbon has three crystalline allotropes, namely the diamond, graphite, and fullerenes. You can see here a diamond, graphite, and fullerene ring in the shape of a football, right? So, moving towards the first allotrope, that is diamond. If we talk about the properties of diamond, so diamond is the hardest natural occurring substance present on the earth. Also, it is clear, transparent, and it sparkles in the light. And also the diamond is a poor conductor of heat and electricity as it do not have any free electrons in its structure. Also, its melting point is very high. The density of diamond is also very high, right? Diamond has very high density, that is comparable to 3.5 gram per centimeter cube. Now talking about the uses of diamonds. So some of the uses of diamonds are given below. So diamond is used first as a tool for cutting glass and drilling rocks. As we know that diamond is the hardest material present on the earth. That's why it is used for precisely cut the glass and drilling in the rocks. Now also it is used in making high precision thermometers because as diamond is very hard, its molecules are very closely packed. That's why it is used in high precision thermometers to detect the temperature. Now, also diamond is used by the eye surgeons to remove cataract from the eye with great precision or accuracy. So basically, cataract is a condition in which, suppose this is our eye and this is our eye lens. So somehow there is a white covering covers the whole eye lens. That's why this condition is known as cataract, and this cataract is removed by using diamond cutters by eye surgeons. Also, diamond is used for making protective windows in the spacecraft as diamond is transparent and also it is resistant to radiation that is present in the outer space and its thermal conductivity, right? Now, in the last, diamond is also used for making jewelries as it sparkles brightly, right? So these are the uses of diamond. Graphite. So graphite is soft, dark, and greasy solid. It is represented by the symbol C as it is a allotrope of carbon itself. Okay, you can see here, this is the image of a graphite rock. So if we talk about the structure of graphite, in graphite, carbon atoms are arranged in parallel layers which can be slide over each other. If we talk more deeply on it, you will see hexagon rings like this in graphite structure present layer by layer on each other which are held together by weak forces, right? That's why these two layers can slide over each other. You can see here in hexagon rings, these layers are arranged. Within each layer, each carbon is joined with three other carbon atoms very strongly. However, carbon atom bonded to adjacent layer are held together by weak forces as I tell here. This is why the different layers can slide over each other. If we talk about the properties of graphite, graphite is soft, opaque and slippery. It is grayish black in color. It is a good conductor of heat and electricity as it has free electron to conduct the electricity. Also, it has a high density and high melting point. It is lustrous. Okay, graphite has lower density than diamond, that is around 2.2 gram per centimeter cube. If we talk about the uses of graphite, so graphite is used in many purposes. The first is graphite is used as a pencil lead. You see the pencil you use to write has a graphite lead as it marks black spots on writing or on friction. Also, graphite is used as a lubricant. So as I mentioned that graphite layer slides over each other as they are held together by weak forces. That's why this is also used as a lubricant, right? Now, graphite is used for making electrodes. As graphite conducts electricity, being a good conductor of electricity, is used to make electrodes for dry cells and also for the electrolysis process. The last use is graphite is used for making crucibles. So a graphite has very high melting point, that is around 3700 degrees Celsius. It is used to make crucibles. Crucibles are special containers used to laboratories to melt or heat metals and solids with high melting point. So these are the some uses of graphite. Moving towards the fullerene rings. So, fullerenes are a class of carbon nanotropes where carbon atoms are arranged in hollow cage-like structures. Fullerene could be spherical, cylindrical, eclipsed in shape. The most well-known fullerene ring is the C60 ring, known as the Buckminster fullerene allotrope of carbon, which has a spherical structure you can see here, like this. It is composed of 60 carbon atoms arranged in pattern of 20 hexagon and 12 pentagon rings. You can see here a football-like structure which have this pentagon structure as well as the hexagon structure in a shape of a football attached to each other. So this is all about the allotropes of carbon and their properties. So I hope this topic is now clear to you. Thank you.